Dinosaurs have long been extinct. But animatronics make models look, sound, and move like the real thing. Developed by Walt Disney in the 1960s, this technique is a combination of art and technology. The slit eyes, rows of sharp fangs, and a long, purposeful snout all look stunningly real. With his razor-sharp claws, this velociraptor figure looks ready to leap right at you. First, the designer uses 3D sculpting software to create a detailed digital model of the raptor. Key features such as the size, shape, and number of the teeth are thoroughly documented. The art director approves a small-scale 3D printed model of the figure, before an industrial robotic arm sculpts the full-size figure in 4-pound foam. The density of the foam allows for very precise styling. An artist adds details by hand. He uses precision sculpting tools to draw wrinkles and lines. He brushes melted clay on top of the foam to bring out details and give more realism to the sculpture. The clay needs to solidify before the sculpture can be molded. A figure finisher prepares a mixture of monomer and polymer that is commonly used to make acrylic teeth. He pours the mixture into a mold shaped like the jaw of the raptor. He places the mold in a vacuum chamber. He seals the vacuum chamber lid and starts the vacuum pump. The vacuum pump will lower the pressure inside, forcing air bubbles out from the acrylic mixture. This process makes for an even and consistent casting. These are sharp and strong velociraptor fangs. The figure finisher separates the teeth by hand, then takes a Dremel tool to file down the excess around the base. The acrylic teeth accurately reproduce the shape of the predator's fangs. The figure finisher places the teeth back in the jaw mold. Massive teeth up to an inch long fill the reptile's ferocious mouth. The figure finisher covers the teeth with flesh-covered dental acrylic to form the gums and palate of the creature. Once the mold is filled with acrylic, he puts it in a vacuum chamber where the gums and palate cure. During the vacuuming process, the gums and teeth bond together to form a complete velociraptor denture. To make the reptile's eyeballs, he places a transparent sheet in a vacuum thermoforming system. The vacuformer heats the plastic to make it malleable. The figure finisher pushes the sheet down on an eyeball shape and activates a vacuum pump. Thermoformed eyeballs come in various shapes and sizes. Now, a plastics technician prepares the fiberglass mold. He uses a chopper gun to cover the inside of the plastic mold with flexible fiberglass strands. The technician bonds the strands together with resin. Once the resin has cured, the hard fiberglass shell takes the shape of the initial foam sculpture. Using a jigsaw, a worker cuts the shell at various articulation points. This will allow the figure to move seamlessly once it's assembled on its animated mechanical structure. The technician applies a primer coat with a spray gun. This shell will house the mechanical components, animating the dinosaur's long tail, its strong upper body and neck, the bird-like head, the hand-like front limb, and its powerful hind legs. A technician covers the fiberglass inner shell with a ripstop fabric lining. It will support and reinforce the silicone skin. She installs zippers on the liner to easily take off or put on the skin. The liner fits tightly over the fiberglass and takes the shape of the inner shell. Technicians use liquid silicone rubber to make the figure skin. One technician connects a tube to the shell's mold injection port, while the other technician operates a high-pressure injector. The machine pumps silicone into the mold. The silicone cures inside the mold for a few hours. Then a technician unfastens the bolts that are holding the shell tightly closed. Technicians take the silicone skin out of the injection shell mold. They inspect the skin to make sure there are no defects and that it mimics the features of the initial foam sculpture. They take the skin off the inner shell for manual touch-ups. A technician cleans up the edges of the skin by trimming off small silicone strips called flashing. With small precision scissors, she meticulously trims off all the flashing to make clean, seamless joints. A figure finisher inserts the molded acrylic denture to check its fit in the lower jaw skin. He checks the fit of the thermoformed eyeball between the skin and the shell. A character painter uses an airbrush to paint the skin with silicone paint. He adds multiple layers of paint, giving the finish much more detail and realism. A machinist mills a mechanical part for the metal frame. Thousands of stainless steel and aluminum pieces need machining. He bores out holes for bearings inside each shaft. Each piece can be customized to suit virtually any design and assembly requirement. An electronics engineer tests a control card. Each animated component of the figure is controlled by a card like this one. The electronics engineer connects the card to an oscillator tester to verify that the cylinder responds accurately to the electronic input signal. A program on the card allows precise control over the motion of the cylinder. The cylinders create motion, while the aluminum frame functions as the skeleton supporting the movement. An animator assembles various parts into the mechanical assembly. He connects a cylinder to the metal frame. Each cylinder is dedicated to a specific function in the mechanical assembly. This cylinder activates a finger in the hand assembly, allowing it to curl up in a smooth, seamless motion. The animator attaches the hand assembly to the arm, bolts it on at the elbow, and screws claws on the tip of each finger. The full frame of the figure is assembled on a test bench. A hydraulics and plumbing engineer opens the compressed air valve, which powers the pneumatic cylinders. The show controller runs random programs to test the response of the animatronic dinosaur. They check air pressure variations in the hydraulic cylinder tubes, as well as electronic direction and amplitude commands. A creative director finally puts his seal of approval on the figure. A lot of effort goes into making such a complex machine look like a living creature.